Good morning, everybody. Yeah, I'm Steve Lau. I'm actually Malaysian, but now I'm working in China. So Everfine, actually you can see the Everfine here is actually the one of the leading company, okay, that manufactures the optical test instruments. Okay, so our specialty is on the spectral photometry and also the Corneal photometry. Okay, and you can see here there is a wide variety of the products. Okay, this is our luminance, spectral luminance meter. Okay, colorimeter. So it can measure the display, the luminance level, and also the color. Okay, for the display. This is meant for the display measurement. Okay, and
So we can use this even so as to check the display of the television, LED television.
yes, this is meant for the TV. Okay, not only LED, but also you can use it for some others like organic LED or the latest like the quantum dots LED. Okay, this you can measure it, and then you can do the luminance measurement and also the color uniformity measurement, so that you can know exactly whether the product is meeting the spec or not. Okay, and yeah, if you come here, this is the integrating sphere, but this is a smaller one. Okay.
Does it interpret?
Okay, the integrating sphere. This is meant for the to measure the total flux. Okay, total luminous flux. Okay, as you can see.
This is also used for lights.
Yeah, this is for LED measurement or some others like halogen or compact fluorescent halogen, compact fluorescent lamp. And you can put the lamp here in the middle, or you can put it in the side, from the sides. Okay, and this is connected to the spectrometer. Okay, if you can take a look here, from here, there is a spectrometer. The spectrometer can actually do the to measure the spectral distribution.
So this is the distribution
yeah.
of the light that you had asked.
Yes,
there.
from inside there. And then you can measure, it's actually the halogen lamp, and you can actually calculate the optical parameter, such as the flux and also the color rendering, correlated color temperature, and chromaticity XY coordinates from the spectrometer. Okay, and yeah, if you come here.
Is the same integrator the
Yeah.
one that we saw?
Yeah, so
The
this
big
is
one.
a bigger one, okay? That is, the smaller one is meant for the LED module and LED single LED measurement. And this is the bigger one, okay? You can measure actually you can see the lamp. Okay, the lamp is actually, we edge the lamp to make sure it reaches the stabilization. Okay, the light output must be stabilized before we do the measurement.
How long does it take for it to stabilize?
Okay, it depends on the the LED itself, the lamp itself. Normally it takes about 30 minutes, okay, to stabilize. And you can see here, the inside the sphere is coated, okay, white. Okay, there is a scientific terms that we call the spectral, the reflectivity of the sphere is about 97 or 98%. Okay, for LED you need a lot of good reflectivity. Okay, so we designed the sphere in accordance to the CIE standards. CIE 84, CIE 127. So we Everfine, we actually strictly follow the CIE recommendation. It's actually the International Committee on Illumination.
Follow only the CIE recommendation.
Not only CIE, but CIE is actually the international standard who who defines all the light measurement requirement. Okay, it's actually the International Committee on Illumination. Okay, where we participated in the CIE Division 2. Okay, so it's mainly meant for the calibration and measurement requirements. So you can see all this. Okay, the design, the measurement. This is connected to the spectrometer, and there's a wafer. There's a wafer for the sphere to make sure that the light from the device under test is not fallen directly to the detector. That would be a wrong measurement. Okay, so yeah, you can see here. Yeah. Okay, let me close it. Okay, if you come over there. Okay. Okay, you can see this is a very huge, giant robotic arms. Okay, and this is one of our very famous product, and we got a lot of patents for this product. Okay.
Let me know that what is this product actually and what is its working?
Okay, so it's a good question. This is what we call as a Gonyo photometer. Okay. Gonyo photometer, and this is to measure the light intensity distribution of the lamp from the LED. So if you talk about the parameter like intensity, luminous intensity, and the flux distribution, okay, you can actually measure it using this.
What type of lights?
Okay, this could be used for the LED and even the conventional lighting like halogen lamp.
What type of LED lights? Because we have LED lights starting from a small bulb to a big, you can say a big wall washer.
The light bulb, and also even for luminaires. Okay, you can use this. As you can see here, there is a luminaires already on it.
With the street lights?
Yeah, it's actually meant for the You can
Street light.
yeah, street lighting, and you can see it's based up, and then there are detectors. You can see a mirror here. Okay, you can see there's a mirror, and then there are detectors. Okay, these two detectors is meant for the near field. Okay, if you want to do the near field measurement, you must put this off, close this,
Okay.
and this is directly seeing the light. Okay, and then you can do the measurement and you can get the intensity distribution. If you want to do the far field, then you need another mirror. Okay, there will be a second mirror which will be placed here, but 50 meters or longer, or 10 meters away. So the light will be reflected from this to the mirror and go to that another mirror and coming back to the detectors. Okay, and then so when this is rotating, okay, this could be also rotated. Okay, this could be rotated for the C and the gamma plane measurement.
Okay.
Okay, and then from that you can actually measure the intensity distribution, and then you can calculate the beam angle. And then if the lights is a spot lighting, so it has a very narrow angle distribution. If it is a glow light or very wide angle, then it has a very wide angle distribution. So
Where do we take the measurements actually?
the measurement is done via this detector.
Does this
The-
require a dark room?
Yeah, this is a detector. Yeah, you need a dark room. Actually, you will need a dark room for this, okay? To make sure the light is not going to the detectors. There were a question on how the measurement results, okay, coming out from this equipment. So this will be connected to a computer, okay, and the computer will actually do all the calculation, and also the results will come out from the computer. And this, after you do the measurement, it's very easy. The measurement is done automatically. Okay, you don't need to worry about the measurement is done. And then after that, it's very easy. You can print out the test results. Okay, and yeah, many lab has actually used our equipment, and they have passed the accreditation. Okay, even for the NAVLab, for Energy Star. NAVLab stands for the National Voluntary Laboratory Accreditation Program. It's recognized by the United States government. Okay, so yeah, we pass everything, no problem. So this is if you can see here, this is another type of the goniometer.
Yeah.
Okay, that one is the C type, and this is the B type. And you can see here, this could be rotated. This could be rotated, okay, vertically, and this also could be rotated horizontally. Okay, and normally there will be a detector from there seeing the light. Okay.
As the B type and this type as a C type.
Okay, this is defined. This is a very good question. This is defined in the CIE document. Okay, in the 84 there is a requirement. Okay, how the light is being rotated.
Okay,
then
based on that you
based on
say-
that we can actually see define whether a B type or the C type. Okay, so yeah, you can see here this is rotating. Okay, so just to let you know, all this equipment we have sold it to worldwide. Okay, not only in India. In India we receive a lot of the customer require for this, but we also sell it to some other country, any countries, okay? United States, Canada, Australia, and as long as you name it, we have the customer, okay?
Why do we want to rotate this plane? We can also measure the light, intensity when it's in a straight line, like we measured there. It was kind of we wanted the light to be steady for some time, and then we measured it.
Okay, this is a very good question. If you compare to this integrating sphere, it is actually doing the measurement, okay? It's not rotating. The lamp is static inside the sphere because you just want to measure the total light outputs. Whereas here, you need to measure how light is being distributed in a space.
Okay.
In a space. So that's why you are measuring the spatial distribution of the light outputs. So you need to rotate the lamp, okay, with a different angle. You need to capture the intensity of the light in a different angle. So you need to rotate it.
So that would mean that here we are measuring the intensity in a room. So we are trying to find out that how big a room can actually accommodate these kind of lights.
Yeah, if you want to measure, it depends on the length of the device under test. Okay, if it is big, then you need a big gonio. Okay, and you need a big distance and also a big room, of course, big room for the measurement to get an accurate measurement.
Great.